Hello everyone, my name is Migisha Kevin. I am with my colleague Kailango Ellen and Kamaliza Anita. So we are from Group 7, Agronomy and Subgroup 6. Here we have the main topic which we are going to develop, which is called humidity. So here we have the table of contents which shows the topic we are going to develop. Firstly, we are going to see the introduction to the humidity. Secondly, we are going to see the tools for measuring humidity. Thirdly, we are going to see the factors affecting humidity, not only factors, and also we have types of humidity, and also we are going to see the measurement of humidity. In addition, we are going to see the effects of humidity on crop plants, and also lastly, we are going to see the relationship between humidity and temperature. So I would like to invite you to follow this presentation. So before going to develop our topic, here we have this question which is going to help us to know more about the topic of humidity. So firstly, we are going to challenge you, think about this question. Here we have question which is at least 7, so allow me to continue to our topic, and we are going to come up with this question after our presentation. So on this slide you have question number 5, which is said that in which environment is humidity typically higher, near a larger body of water or in desert? Here we have multiple choice, and also on question number 6 it says that why is it important for agriculturists to monitor humidity level in greenhouse? This is another question. So the question number 7 is said that which of the following is the consequences of excessively high humidity in agriculture? So this is, you are going to think about it, and we are going to come up on this after our presentation.
Hello, my name is Kamaliza Anita. I'm from Group 7 Agronomy, Subgroup 6. We are talking about humidity. Introduction about humidity. The quantity of water vapor in the air is called humidity. In agriculture, the moisture content of the air around plants and crops is frequently referred by the term humidity. The level of humidity in air is determined by factors such as temperature, pressure, amount of water vapor present in the atmosphere. Let's continue. Here we have absolute humidity, which is the total mass of water vapor in specific volume of air measured in gram per cubic meter or gram per kilogram of air, and accurately indicate the actual concentration of water vapor in the atmosphere. Here we have a graph which is showing the amount of air at 100%, which is relative humidity across a range of temperature. Let's continue by the tools used for measuring humidity. A thermohygrograph. This instrument, called thermohygrograph, is used in meteorology, agriculture, and industry to track environmental conditions for analysis and decision making. It continuously collects temperature and humidity data.
So here we have another tool which is called thermohygrometer, displaying temperature and relative humidity. This tool, a thermohygrometer, uses temperature and humidity sensor to measure environmental conditions. It is aiding in climatic control, energy efficiency, and they are also used in pharmaceutical manufacturing. Here in our research, we have seen the third tool, which is called hygrometer for domestic use, wet or dry psychrometer type. A wet or dry hygrometer for domestic use measure humidity by comparing the temperature of a wet bulb and dry bulb thermometer. This is for calculating relative humidity. It is also utilized in home to maintain comfort level and prevent mold growth, and also it optimizes conditions for indoor plants.
Hello everyone, I'm Eden Kairangwa from Group 7 Agronomy and Subgroup 6, and I'm here to continue to the factors influencing humidity. Let's start with human activities. Human activities such as industrial process, agriculture, and urbanization can be contributed to changes in local humidity levels. Factors like deforestation, irrigation practice, and pollution can alter nature moisture cycles and impact regional humidity patterns. Second factor is pressure. Atmospheric pressure can be affect humidity by influencing the rate at which water evaporates and condenses. High pressure systems generally promote clear skies and low humidity levels, while low pressure systems may lead to cloud formation and increased humidity. And the third factor is weather conditions. Weather patterns such as rainfall, fog, and clear sky can affect humidity level. Rainfall adds moisture to the air, increasing humidity, while clear sky and dry conditions can lead to low humidity levels. And the fifth one is time of day. High humidity levels fluctuate throughout the day based on temperature variations. Relative humidity is typically highest around sunrise when temperatures are lower and decreased as temperature rises during the day, reaching the lower point in the afternoon.
So here we are going to see the types of humidity. Firstly, we are going to see the relative humidity. On relative humidity, we have sea level, how it lies, and how melting of ice is working, and the precipitation, and the relative humidity percentage. So by here we have the graph which shows us relative humidity in percentage. So we have four graphs which is going to help us to comparing relative humidity. So here we have the first graph which it shows the relative humidity comparison. So as you see on this graph, relative humidity represents amount of water in air in percentage. So for the first graph we have relative humidity which is 0%, which means that the amount of water in air is absent, is 0%. On the second graph we have relative humidity which is 50%, which shows amount of water in air it is increasing. So this means that as we see amount of water in air when it is increasing, and also the relative humidity it also increase. And also on the third graph we have 75% of relative humidity, and also it shows how amount of water in air it's also increasing. On the fourth graph we have 100% of relative humidity, which means that the relative humidity amount of water in air is also increasing.
And here the relative humidity is a percentage and compares the actual amount of water vapor present in the air to the maximum amount it can hold at a specific temperature. Warmer air can hold more moisture than cooler air, so relative humidity varies with temperature. It indicates how close the air is to saturation. And let's go on the factor that affect relative humidity. The first is amount of water. If you increase the amount of water in the air by adding it due to evaporation, the relative humidity will go up. And the second factor is temperature. Since warm air can hold more water than cold air, If you lower the temperature, the relative humidity will go up, even if you don't add more water. And the second type of humidity is absolute humidity. Is expressed in gram per meter cube. Measures the total water vapor in air, regardless of temperature. Its brochure in meteorology, climate research, and industrial applications like manufacturing, agriculture, and indoor air quality management for precise moisture control. And the specific humidity. Specific humidity refers to the actual mass of water vapor present in a mixture of air and the water vapor, and it's expressed as level of the mass of water vapor to the total mass of moisture. It is typically measured in grams of water vapor per kilometer of air and is independent of temperature and pressure. And let us move on the measurement of humidity. First one is hygrometer. As we see here, there is the instrument used to measure humidity called the hygrometer. Hygrometer is an instrument which measures the humidity of air or some other gas. That is how much water vapor it contains. Humidity measurement instruments usually rely on measurements of some other qualities such as temperature, pressure, mass, and mechanical or electrical change in a substance as moisture is absorbed. Let us continue to the difference between relative humidity and the absolute humidity. On the table below, we will see how the difference between the relative humidity and absolute humidity takes. As I said on the previous slide, we are going to continue to the difference between absolute humidity and the relative humidity. Let's start their difference in the form of the definitions. Absolute humidity is the mass of water vapor per unit volume of moist air, while relative humidity is a percentage of the partial pressure of the water vapor divided by the saturated vapor pressure at the given temperature. This is the first difference between both types. And the second one is the measurement. The difference between both types in the form of measurement at the side of absolute humidity is the measure of water vapor in the air regardless of the temperature, while on the relative humidity is a measure of water vapor measured relative to the temperature of the air. The third difference is about the volume. The volume on the side of absolute humidity is a fraction, while on the side of relative humidity, volume is a percentage. The fourth difference is about the detail given. The detail given on the side of absolute humidity, a detail cannot be given on the measure of the real conditions since it depends on the temperature. While relative humidity on the detail given gives a good view of the conditions since saturated pressure depends on the temperature. And the last one is temperature. Temperature on the side of absolute humidity, it is independent on the temperature, while on the side of the relative humidity, temperature it depends on the temperature. Okay, thank you for your kind attention, and let me welcome my colleague to continue to the another slide.
Let's continue on the impact of humidity on a crop. On positive side, we have prevention of water stress. By maintaining adequate moisture in the air, plants can regulate their water balance more efficiently, reducing the risk of wilting and dehydration. Other point, enhance nutrition uptake. Optimal humidity support proper nutrition uptake by plant. When humidity levels are suitable, plants can absorb essential minerals from the soil more efficiently, promoting overall growth and development. At that point, optimal photosynthesis. Humidity regulates how quickly plants transpire, which in turn affects the capacity plants are to absorb nutrients and water. An efficient photosynthesis environment is created by moderate humidity level, allowing promote rapid plant development and better yield.
So here we have structure of transpiration process. The transpiration is loss of water from plants. And also we have xylem tube, which is transferring water and other nutrients into the plant. And also we have the stomata, which it helps the plant for relaxation. And also we have water travel uptake through the xylem tube, we have said before, and we have water evaporation through stomata in leaves, and also we have the soil, and also we have water enter to the root. So allow me to continue to the positive impacts of humidity on crop plant. The fourth, we have diseases prevention. Certain diseases of plant carried on bacteria and fungi can be stopped in their track by maintaining balanced humidity level. While reasonable for humidity level help to keep diseases at bay and support healthy crop. High humidity may promote a situation that is friendly to pathogen. And also we have improved pollination. Optimal humidity level contribute to better pollination, especially for crops that rely on insects or wind for pollination. Adequate moisture in the air helps pollen grains stay hydrated and viable, facilitating successful fertilization and fruit set. And also we have better fruit quality. During the fruit development, appropriate humidity level can be improved the size, flavor, and the general quality of harvested fruit. Maintaining stable moisture level helps fruit ripen and form and lower the risk for issues like blossom, aids, and root cracking.
We are going to continue on the negative impact of humidity on crop plant. Here on the first we have plant which is affected by too little humidity, where the leaf tip brown and shrived, and on the lower leaf edge turn yellow, wilting start to occur, and the bud and flowers shrived and fall. Leaves fall in if plant is very sensitive to dry air. On the lower plant we have dangerous when humidity is too much. On the top leaf, patches of the grey mold on leaves, as observed on the figure. On the lower leaf, patches of the rot on the leaves or stem, and succulent very sensitive. Let's continue on the negative impact of the humidity. Reduced photosynthesis. When the air is saturated with moisture, it becomes difficult for plants to absorb carbon dioxide. As we know, carbon dioxide is essential for plants in its photosynthesis. Then we have poor pollination. High humidity can affect the activity of pollinators such as bees and butterflies. Excessive moisture in the air can make it challenging for these insects to navigate, reducing their ability to transfer pollen between flowers. Then other impact is increased transpiration. In high humidity, when the air is already saturated with moisture, plants transpire less, potentially leading to waterlogging and nutrient deficiency. In addition to negative impact, here we have nutrient imbalance. Excessive moisture in the soil can hinder the root ability to absorb plant nutrient efficiently, leading to nutrient imbalance and deficiencies in crops. And number 5, we have stunted growth. High humidity can result in a reduced evapotranspiration rate in plants. Evapotranspiration is crucial for maintaining target pressure in plant cells and facilitating nutrient transport. When evapotranspiration is compromised due to high humidity, plants may experience stunted growth, weak stems, and overall reduced vigor.
Thanks. Before I continue about the relationship between humidity and temperature, my colleague Anita has said about the importance or impacts of humidity on crop plant. So we have seen prevention of water stress on the impacts of humidity, which is positive, and also we have seen enhanced nutrient uptake, and also we have seen diseases prevention, and also we have seen improved pollination, and also we have seen better fruit quality. And on the negative impact of humidity on crop plant, we have seen reduced photosynthesis, and we have seen poor pollination, and also we have seen increased transpiration. So we are going to continue talk about the relationship between humidity and temperature. Firstly, we have weather pattern. Temperature and humidity variation influence weather pattern, such as the formation of clouds, precipitation, and the intensity of storm. Secondly, we have temperature and humidity level affect the plant growth and agriculture. Influencing factors like transpiration rate, soil moisture, and the susceptibility to diseases. The thirdly, we have high humidity level combined with high temperature can result in uncomfortable conditions due to reduced evaporative cooling efficiency, while lowering humidity with high temperature can lead to dryness and discomfort. I'll use on this point. Let me repeat again. High humidity level combined with high temperature can result in uncomfortable condition due to reduced evaporative cooling efficiency, while lowering humidity with high temperature can lead to dryness and discomfort. So by continuing to the relationship between humidity and temperature, here we have humidity indicate the likelihood for precipitation, dew or fog to be present. Humidity depends on the temperature and pressure we have seen as the factor that affecting humidity. And also we have condensation. Condensation, it says about high humidity level increase the likelihood of condensation forming on surface when they cool the dew point temperature. And also we have evaporation rate. The evaporation rate says that high temperature tends to increase the rate of evaporation of water, contributing to high humidity level if the moisture is not removed from the air. So allow me to continue talking about the relationship between humidity and temperature. Here we have the graph which is going to show us the relationship between humidity and temperature. So on the left side you have temperature, and also on the right side you have humidity. So the line which is up here blue, it shows us temperature, and the line which shows us orange, it shows us humidity. And also at the bottom of this graph we have the time. So as we see, from A to C, the temperature is increasing, and also from on the line which is yellow, the humidity is decreasing. So as the temperature increases, the humidity also it decreases. And also at the end of this graph we have the rising of humidity and you have decline of temperature. So this is the relationship between humidity and temperature. So thank you for following this presentation, and as we have said in the first slide, we are going to answer the question which we have seen in the first slide.
Thank you. We are going to continue on the answers for interactive questions. The first question was, what is the definition of humidity? The correct answer is B, the amount of water vapor in the air. Question number 2, which unit is commonly used to measure humidity? The answer is C, percent. Question 3, what effect does high humidity have on human comfort? The answer is B, makes the air feel damp and sticky. Let's continue. On number 4, what is the term used to describe the point at which the air is saturated with moisture and condensation begins to form? This point is called dew point. The right answer is A. Number 5, in which environment is humidity typically higher? The correct answer is near a large body of water. The answer is A. Question number 6. Why is it important for agriculturists to monitor humidity level in greenhouses? The right answer is C. To optimize growing conditions for crops. Number 7. Which of the following is consequence of excessive high humidity in agriculture? The right answer is C, which is promotion of fungal diseases. Thank you. This is the end of interactive questions.
Thank you again. We are going to conclude about our topic, which is called humidity. So before we have seen the topic of humidity and we develop it, and we have seen many things, and I hope that you understand more. In conclusion, humidity refers to amount of moisture or water vapor present in air. It is influenced by factors such as temperature, evaporation, and condensation. And also, humidity plays a crucial role in shaping our environment. We have seen it, how it shapes our environment on crop or other things. And also it influences everything from our daily comfort to large-scale weather pattern. We have explored how humidity interacts with temperature, as we have seen in their relationship, and how it's affecting phenomena like dew point, heat index, and evaporation rates. Understanding this relationship is essential for various fields including meteorology, agriculture, and also to the human health. Thank you for our presentation. So before going here, we have bibliography, or what we say where we conduct our research. So here we have the link which shows our image and where we found it. So in short summary, we have make a research on Google's, on Wikipedia, other website. So this link show us how this presentation, or how this image which we have seen in our presentation where we conduct it. And also this slide is show us the website which we can visit and show us more detail about these topics, which is called humidity. So this also the link which will help us to enter it and show us more information about our topic. So thank you for your kind attention and watching our presentation. So may God bless you.